Welcome, welcome, guys. Hello, hello. Welcome to our GRE Prep Hour. How is everybody doing this evening? But again, welcome. My name's Whitney. I'm in Durham, North Carolina, right over here by Duke University. Been teaching for Manhattan Prep since 2010, which is crazy to me. Just had my 10-year anniversary earlier this year. And we are going to cover a quant topic tonight that is a favorite of mine. We are going to talk about functions, formulas, and sequences. So we are talking about the crazy notation problems on the GRE. And what I would like is by the end of tonight, I want you to be able to recognize these question types. They're pretty easily recognizable, which makes them some of my favorites because they kind of like jump off the page at you. I want to make sure that you're comfortable translating weird notation, translating sequences notation, and that sort of thing. And then we're also going to talk about when the computation gets crazy or when the question implies some crazy computation, how can we spot patterns to try and avoid some of that computation? All right, so let's start with functions. And so a lot of us are more comfortable, and thank you for my happy 10 years, I appreciate that. A lot of us are more comfortable with our standard, what I'd call like school notation, this like f of x. That's how we would read this expression, f of x, where in this notation, x, the variable, is what we're going to like write an expression with. And just this like f of x is symbolic notation. But we're going to extend on that and move into how the GRE decides that, standard school notation just is not complicated enough. They're going to just make up notation. And the best part about this is that for a lot of the problems we're going to see tonight, functions, sequences in particular, the notation is scary enough. And so the questions themselves don't even need to be that hard because most people are scared off by like weird symbols, lots and lots of words. And so what I want you to see is that a lot of times these functions and sequences question, the difficulty is just getting past the notation. The work itself is usually pretty easy. And so these can be some cool problems to like collect some of those points on if we can just like breathe and not let them rattle us with all the weird symbols. So I want to start with a question and give you guys a chance to try out the problems that we're working on tonight. I'm going to give you a stopwatch with a timer counting up. Your average time for these like multiple choice style questions on the GRE is going to be about 2 minutes. For the section as a whole, average time is about 1:45. But we'll take a little bit longer with some of these because for those of you that have been studying the GRE already, there's another question type called quantitative comparisons. And we are attempting to try and finish the quantitative comparisons in more like 1:15 so that we have a little more time for these. Just so you know, if you are looking for any of these questions, they can all be found in our 5-pound book. You can purchase that on Amazon from us directly. Cool, so I'm gonna give you a stopwatch. Send me privately, so to all panelists, your answer when you think you got it. Nice, guys, nice. So as I am getting answers from a ton of you, it is really clear that this, high school style function is pretty easy to manipulate, right? the way we want to make sure that we can read it. And so we're going to add some layers here. And so I want to start with this one that's a little bit easier. The way we want to read this notation is that anytime you write this letter F and put some number or some term in here, you will rewrite the right-hand side using that number in the place of the variable. So F of 2 would be replacing X with the number 2 everywhere, right? So we would put in a 2 squared plus 1. Now notice that I kind of like quarantined that number when I plugged it in. And the reason why I did so is I want to make sure that, in this case, X is being squared, the whole value. I don't want to lose something, like in this second one, F of -2. I don't want to lose that negative sign. It needs to be squared as well. So F of 2 is 4 plus 1 is 5. F of -2 is 4 plus 1 is 5. I'm looking for the sum of those two things. So I find my value of this function. I find my value of this function. I add them. When something is inside of a function, you can think of it as kind of your PEMDAS, the order of operations. You have to sort out the function first. And so you wouldn't just add the 2 and the -2 first. You actually would calculate the function. So the sum of these is 5 plus 5 is 10. Nicely done, you guys. Very nice. Lots of E10 floating around out there. Okay, so what we can do then is start to make things a little weird. So let's keep this on the same page for a second. What if I asked you, what is F of M? I want you to type that to me. What do you think that would be? F of M. What would F of M be? What is F of M? Nice, guys. Starting to see them come in. I am literally going to replace the variable X with the variable M. And so M squared plus 1. Just replace. And same thing goes if I said F of, let's call it M plus 1. I would wrap that whole thing, M plus 1 squared plus 1. Let's square this thing out. So note that what I'm going to do is I'm going to, in an F of X or G of X or P of X or whatever letter they stick out front, if I have an F of X and then I rewrite it as F of some other thing, that other thing just plugs in the place of X. Okay, what if I told you that F of, let's try a different one, F of P equals 2. What in the world do I do with that? F of P equals 2. Keep thinking about it. I'm going to give you guys a little bit more time to think for those of you that haven't come up with it. Yeah, we're going to replace. We're going to take this side. This side is F of P. So I need to rewrite it. That would be P squared plus 1. That equals 2. So then I would solve for P if that's what they asked me to do. I'd subtract a 1 from both sides. I would get that P squared is equal to 1. And then what numbers, when I square them, are equal to 1? P equals 1 or -1. Right? I'd want to remember both signs. So in this case, P could be either 1 or -1. Either one. Okay, cool. So this is really the way we would start to think about complicating. One final layer, and then we'll try a couple problems. What if I said F of 2? What's that one going to look like? All right, so we've made it sufficiently tricky. Right? We've made it sufficiently tricky. So I had a great question in the background. If we've been given two answers, P is 1 or -1, yeah, if it's multiple choice, only one of those would be there. You wouldn't have to guess which of the two it was. Yeah, for sure. It would say something like which of the following could be the value. But if we're going to do something like this guy, f of 2, we have to do this just like PEMDAS. We have to start in the inside. So the first thing I'll do is I'll keep my f, and then I'm going to find my first f of 2, which we already figured out would be 2 squared plus 1, which equals f of, once we simplify this, 5. From there, I would then plug this back into it again. 5 squared plus 1, or 25 plus 1 is 26. Yep. And so we're just going to like sort of start on the inside and wrap it and keep going on the way out as many times as they want us to do it. If we had more than one function, we could layer them inside of one another. So an example there might be, let's say that f of x is x squared, and g of x is 2x. Then we could calculate f of g of x, or g of f of x. Take a moment to think about what those two would look like. I'm starting to get some answers in. If I want f of g of x, I'm going to replace the g of x in here, and I'm going to find f of 2x. Well, f of a number is that number squared. So f of 2x is going to be 2x squared, or 4x squared. If I went the other way around, f of x is x squared, so I plug that in. So I want g of x squared. Well, g of a number is equal to 2 times that number. So in this case, it's going to be 2 times x squared. So notice that the order that we put the g or the f changes the value. It changes our value. So let's try a couple. Yeah, let's try a couple and think about some of our time for these. We're looking to try and finish again in about a minute and 45. Nice. I'm getting lots of answers in, and I want you to notice that once we know how to translate this type of problem, kind of break it down, often we're able to finish function and sequence problems in a lot less time than is expected. Um, often what slows people down on these is like kind of the freak out about notation. Yeah. So it's worth practicing. If I want or if I'm told that h of x, I'll get this on my paper. Help if I use the right variables. So if h of x is going to be, so h of some number is going to be 2 times that number cubed minus 3, then h of m is going to be 2m cubed minus 3. If that equals negative 19, then I solve. I'm going to add a 3 to both sides. So 2m cubed equals 16. I'm going to divide both sides by 2. So m cubed equals 8. What number when I cube it equals 8? Oh, excuse me, negative 8. Okay. That would be a negative 2. So the correct answer is B for everybody who put that down. Beautifully done. Beautifully done. All right, well, you should know how to do this one then pretty quickly. Same sort of style. We just got a layer. Let's see how quickly but accurately you can get this one sorted. Nice. Lots of answers coming in quickly. So if I want the f of 10, my first f of 10 is going to be 10 over 2 minus 1. So that gives me 5 minus 1 is 4. I'm going to stick that one in there, which then becomes 4 over 2 minus 1 is 2 minus 1 or 1. Beautifully done, guys. Right? So once we get used to this f of x notation, life is kind to us. The GRE says that's not enough, right? That's too easy. People find that way too simple. So we're just going to make it look a little freakier and give you a weird symbol that doesn't mean anything, but we're going to make it mean something. So on test day, if you ever see a symbol that is like, I don't know what that symbol means. Oh, great question. We'll talk about that after this one. But if I see a symbol and I have no idea what that symbol means, then I know that this is a function problem and they're going to have to define that symbol for me. So let's take a moment and try this one. Again, I'll give you a timer counting up and then I'll explain why I love an up counter when you're studying. All right, lots of answers coming in. Lots of answers coming in. So I had a couple of people say, and I love this, like, I have never seen anything like this. I didn't see anything like this, not even in high school. And the fact is, you're right. You're right. You did not. And that's the idea here is that they know you've seen f of x or g of x or what have you. So they want to make it more complicated. So instead of using the notation f of x, they make up new notation. What this really says is f of x equals 2x squared plus 2. So what is f of 4? Instead of writing F with parentheses, they gave you this weird symbol. That's all this is, right? So they want to show you this crazy symbol and they want to freak you out. They want to freak you out. So what is F of 4? Well, F of 4 is equal to, well, 4 squared is 16. So we'll take 2 times 4 squared. We're going to add 2 to it. And so when I square 4, that's 16 times 2 is 32 plus 2. And so 32 plus 2 is 34. And I want to find which of the following of these is equal to 34. I want to remember that every time I see this little symbol, right? Every time I see this little symbol, it's really just one of these f of x. So some of this computation looks awful because now what it looks like they're asking me to do is to compute for all of these, which is craziness. I don't want to compute for all of those. So I want to think carefully about it. I want to do some elimination. Note that if they layer them, like say in A where this guy gets layered, that's the same as saying f of f of, and then the negative 1 goes inside. They're just giving you weird notation to make it more complicated. So if what I know is that f of 4, or this like weird bracket symbol of 4, is equal to 34, I want to look for an answer choice that once I start plugging stuff in, and the layered ones are going to be more complicated, but once I start plugging stuff in, is going to give me the same 34. Are there any? Well, so that's a great question. This is confusing. What's a good way to remember the difference between the two lines? There isn't a difference between the two lines. Every time you see something wrapped in a line, you know what that is. It's this. So what you would do for this top one, and so we'll run through this one to try. You're going to do this. You're going to say, okay, I keep the outer bracket. We're doing it just like PEMDAS. We're working from the inside out. I'm going to keep this outer bracket, and I'm going to figure out this inner bracket. So the inner bracket is replacing x with negative 1. So 2 times negative 1 squared plus 2. All of that is kind of under one of these weird brackets. So this kind of weird bracket thing, negative 1 squared is 1 times 2 is 2 plus another 2 is 4. And so all of this, right, like 2 plus 2 equals, and then I would have to find this bracket of 4, except that I don't have to find the bracket of 4 because that's actually what I'm looking for. But let's try it with C, just to see it again. Bracket of 2. So we start with the innermost bracket, just like PEMDAS would say, parentheses, and then you work way out. This would be 2 times 2 squared plus 2. And then we're going to simplify that math. So 4 times 2 is 8 plus 2. So this would want the bracket of 10. To find the bracket of 10, I now plug that in. So this is just like when we took the f of g of a thing, or like the f of a thing. You just keep taking it of itself. And so we now would say to plug in this 10 plus 2. We plug it into this original function. This is one of the more confusing ones because this notation is crazy. But in this case, this would be 202, which is way too big. The correct answer on this one is A. What you'd want to start to notice, though, are there any? You might. It would depend. It would depend. It would depend. If you could get one of these to look like it like we did, that was enough. But it might have been that it was like another number that got us into the same place. And so we had to actually calculate it out. Great question, though. So we might need to calculate it. But if I were going to take bracket of 17, that result would be 2 times 17 squared plus 2. That's going to be way too big. Bracket of 34 would be 2 times 34 squared plus 2, right? I'm looking for 34, not bracket of 34. And so that won't go. So we could do some eliminations if we did that like computation of the initial function. Yeah, so be careful. We aren't looking for bracket 34 because bracket 34 would actually equal 2 times 34 squared plus 2. Right. So great question was, well, so why did we even calculate this if it popped out of this function? It might not necessarily pop out of this function. Right? It might not. Because you might end up with a situation where they created a way for this layered of function to equal 34. So in this case, it turned out that A was, bracket 4, and maybe you start there. Maybe you run through a couple of these and see, but you would want to check. 4 equals 2x squared plus 2. That was just a coincidence. And again, so a couple people have asked the same thing. The reason why we bothered to solve this for 34 is we weren't guaranteed that the answer choice was going to actually show up bracket 4. The answer choice might have, just the way it was built, still given us the number 34, but with something different in the layers. I would say that for a problem like this one, you would want it to take under 2 minutes, just like any of the rest of them. Let's try one, which was the equivalent of asking f of x equals 4. Not quite right. So this was the equivalent. If you wanted to translate this into an f of something notation, right, this would literally be if f of x equals 2x squared plus 2, then which of the following is equal to f of 4? And the answer choices would be A would be f of -1. Answer choice B would be f of -2. C would be f of 2, layered. D would be f of 17. E would be f of 34. So if this is your function, and let's look at another version and maybe pop back to this one because it can help sometimes, see layers. If this is your function, that's the equivalent of this part out here. It's just written in a different way. So let's try another one with some weird notation. It might help, and we can come back to this one. This one's going to be kind of bizarro. What do I do with something that looks like this? Let me take a moment just to kind of see what happens when you poke at it a minute. So notice it's the same kind of weird notation. Literally all it says is when you see this weird hash, when you see that, whatever numbers on the left-hand side goes where all the A's are. Whatever numbers on the right-hand side goes where all the B's are. That's how I want to interpret it. So, well, yeah, so here's what we're going to do. So let's look at it. I like to sort of stack them. If A hash B equals A squared times the square root of B minus A, then the value of -4 times 4 is that everywhere I see the thing in front of this symbol, it's going to replace all of the A's. And whatever comes to the right of the symbol is going to replace all the B's. So I'll stack them up and go, okay, everywhere I used to see an A, I want to see a -4. So minus a -4. And everywhere where I used to see a B, I want to see a 4. Once you have them all plugged in, now you're going to multiply them through. So -4 once I squared is 16. The square root of 4 is 2. If I subtract a -4, that's the same as adding 4. So 32 plus 4 is 36. Let's try it again. I want to know. Love it. Okay, so I did get one question in the background that's a little bit kind of tangentially related. We saw before that if I tell you that x squared is 4, that implies that x is either 2 or -2. And here's why. Because when I plug 2 in and square it, I get 4. But when I plug a -2 in and square it, I get 4. However, if I told you that x is equal to the square root of 4, that means that x is equal to 2. When I take the square root of a number, I only get a positive result. The reason why we have to think of the positive or negative in these squared situations is that because the thing I don't know is being squared, the thing I don't know could have been positive or negative. Right? So the square root of 4 is always a positive. It's why when we solve these, we often write them as x equals plus or minus the square root of 4, because this square root of 4 is always positive. So x is going to be plus or minus 2. It says that b has to be positive because you're not allowed to take the square root of a negative number. So those are two different concepts, but like related. I'm not allowed to take a square root of something that's negative. So what I want to try then, let's try this. I want to know what is 5 hash 1. I want you guys to try this one. Same formula, but what is 5 hash 1? Nice, guys. Did that make it? For those of you that were messaging like, oh my gosh, I'm kind of confused. How did this one go? Message me. Let me know. How did this one go? Because I'm going to plug it in everywhere where I saw an A. I'm going to make this 5. And everywhere I see a B, I'm going to make that 1. So this becomes 25. The square root of 1 is 1 minus 5. And so 20. Yeah. And they can give you all kinds of crazy versions of this. They could tell you X star Y. And then they could do X star Y is equal to X plus Y squared minus Y or something like that. And then they tell you this, what is 2 star 1? Everywhere there was an X, I put a 2. Everywhere there was a Y, I put a 1. In this case, you'd end up with a situation of 2 plus 1, I square it, and then I'm going to subtract off that 1. So 3 squared minus 1 is 9 minus 1, or it's 8. They could. Yeah, they absolutely could. So I had a great question. Would they ever use an equation? They could. They could say, then what is 2 star X, let's go Y minus X or something like that. And now I would plug in everywhere I see an X, right? And then you'd have to run through this whole mess. You'd plug that in, then plug the 2 in. But now we're getting really, really complicated. And have you noticed that from a lot of these, I don't need to make them more complicated. They're already complicated enough. They're already complicated enough. So if we go back to this problem, these are just that same weird notation. All it's saying is if I put a hook over a number, do this to it. So I'm going to put a hook over 4. In order to figure out what the value of hook over 4 is, I'd plug 4 in here. If I want to know the value of hook over -2, I plug -2 in. If I want hook over 17 or hook over 34, I plug them in. If I take a hook of a hook, that means I got to plug it in once and then plug it back in again. Right? It's all the same thing. These would be considered medium to hard, for sure. For sure. Now, another type, and these look terrifying, but they actually turn out to be pretty easy. Another type of problem is the formula problem. Formula problems look mean because they usually have a ton of text. And really what you need to work on with formulas is maybe don't run away from them once you realize it's a formula problem. And your job is just to get everything on the page. Okay? So notice, oh my goodness, so much. So much. So what I want to do is take a moment to read and get this information on my page. The reason why I use a timer counting up is because when I'm doing individual problems, I just like to record how long they take for me to do naturally. So I can get a sense of, on average, how long certain types of problems take. If I'm doing sets of questions, that's when I set a big timer counting down. So that's why I do individual problems with a timer counting up. All right. So much information. But what I know is they say an archer's score is calculated by this formula. And so I'm going to write that on my paper. I'm going to be like, okay, the score is equal to 50B. And I write my B's as capital letters, even if they give them to me in lowercase, because otherwise they start to look like numbers. Minus 10A over 10 plus S. Where B is bullseyes, so B equals bullseyes, and I might jot this on my paper. A is total arrows. And S is seconds. Now you guys know formulas. What's this formula? What's that formula? Yeah, it's a profit formula. You know this. If I know revenue and I know cost, I plug it in and it spits out profit. If I know profit and I know cost, I plug them in and spits out revenue. This is literally a formula. Everything you learn for geometry, those are just the same. For these types of problems, they're just going to give you a bunch of text and then they're going to give you a formula, right? And it's mostly invented. So I'm trying to compare one archer who took 10 seconds to shoot 10 arrows and got all bullseyes versus an archer who shot twice as many arrows, half as many, and then 15 seconds. So I just have to figure out how to plug all this stuff in. So let's start with our first archer. Right? So our first archer took 10 seconds. We're going to plug that in for S. So 10 plus 10 seconds. He shot 10 arrows. So arrows would be A. So minus 10 times the 10 arrows. He hit all bullseyes, which meant all 10 were also bullseyes. So I'm going to write this as 50 times and plug in a 10 for B. Now let's look at our second archer. This person shot twice as many total arrows. So instead of 10 arrows, they shot 20. So minus 10 times 20. And they hit half as many bullseyes. So instead of getting 10 bullseyes, they only hit 5. Because it says the number of bullseyes hit as in terms of the number of arrows shot. So if we shot a bunch of arrows, how many of those landed as bullseyes? So if all 10 arrows hit bullseyes, then we had 10. So this person hit half as many bullseyes as the first guy. So he only hit 5. And this all happened in 15 seconds. Literally from there, you're just computing. So this guy is 500 minus 100 divided by 20, or 400 over 20. We can cancel out a 0. This is 20. This guy is 250 minus 200 divided by 25. So 50 over 25 is 2. And it says, by how many points would one archer beat the other? This person got 20 points. This person only got 2 points. And so 4. Yeah. And I think that there's a little bit of like muddiness in this language. But if he shot twice as many arrows and hit half as many bullseyes, that would mean like the total number of bullseyes. And if the language seems really complicated in one of these, I had a great comment from somebody. It's like, I don't like these. These are really hard. Maybe you're exactly right. These aren't the ones that you do. Let's try one more. Same idea, right? So you can see what it's like. We're just plugging in. All right. See, there we go. Nice. Nice. So what I want is I want to get the formula on my paper. So monthly rent is this whole mess. So it's K times a bunch of stuff. 5R squared plus 10 times T divided by F plus 5. Okay, K is some constant number. R and T are the number of bedrooms and bathrooms. So R equals bedrooms. So I'm going to make a note to myself. R equals bedrooms. T equals bathrooms. F is the floor. Now they're going to tell me some information. Like what they've left out is this constant. I don't know what K equals. When it says it's a constant, it's just some number. Think about trying to convert Fahrenheit to Celsius. And it's got this like 3/5, 5/3, or whatever it is, constant. So they tell me a 2-bedroom, 2-bathroom unit on the first floor. So if I start to plug that in, a 2-bedroom, 2-bathroom on the first floor, the rent for that is $800. All this is multiplied by this crazy K. So I'm just trying to figure out what in the world this K equals. Here's my K. I've got 800 equals, and then 2 squared is 4 times 5 is 20 plus 20. Did I do like a crazy? I may have done a little crazy math here. 4 and 5. I think I did it right. Over this guy is 6 times K. And 800 equals 40 over 6 times K. And so I'm going to multiply both sides by the reciprocal. So the math, we got to kind of practice, but that means that K is going to equal 800 times 6 over 40. 40 goes into 800 20 times, so 120. So the constant is 120. Once I know that mess, I'm going to plug in how much is the rent for a 3-bedroom, 1-bathroom, 3rd floor unit. Well, I know what K equals. So if K is 120, a 3-bedroom, 1-bathroom on the 3rd floor. At this point, I'm plugging in numbers. Plugging in numbers. So this is 3 squared is 9 times 5 is 45 plus 10 divided by 8. So I've got 120 times 55 divided by 8. And you can break out the calculator for this if you wanted to. You can start to reduce. This is 4 and 60. So 4 goes into 60 15 times. And I'm going to multiply 15 times 55. For that, I'd probably bring out the calculator. The numbers are sort of messy enough. And once I do, maybe. $15 times 55 is 825. Our correct answer is A. So when it comes to a function, there's a lot, right? There's a whole lot here. It's plugging in. Oh yeah, and so I had a couple of questions which I want you guys to see, or I want you guys to hear about is, hey, for something like this, is this a good thing to flag and maybe do way later? My answer to you is absolutely. Absolutely. Right? I know it's a functions problem. And so part of why I set a timer counting up is I want to learn like, oh, I can do a function problem. They're just slow. Or like, I don't mind doing a formula problem. I'm just not that fast at them. So I'm going to save them for last. The last piece with this crazy notation that we're going to do, right, is a sequence. And I just want you to be able to read sequence notation. So again, let's take about a minute just to familiarize with yourself with this and get started on it. And we'll talk about how to solve this and try one more. All right, so a little bit of a tweak, right? It still feels very functiony, but the way, so we noticed when we had the f of x, we would read that f of x. We read this like sequence notation slightly differently. We use the word sub. So this is going to be s sub n. This is s sub n minus 1. And so the way we want to start to think about the relationship between s sub n and s sub n minus 1 is if I wanted, let's say, s sub 5, right? That's what it's looking for. So s sub 5 is what I'm solving for. I always start there. That equals, according to this formula, 2 times, and then I would put the 5 in here, 5 minus 1. This would be s sub 4 minus 4. What they're saying is that the value of the fifth term is based on the value of the fourth term. And the value of the fourth term will be based on the value of the third term. And the base of the third term will be based on the second term. The second term will be based on the first term. So if I want to know s sub 4, so s sub 4 is going to be 2 times s sub 3 minus 4. And s sub 3 is equal to 2 times s sub 2. So then I have one more. I'm going to take it another degree. And so my last one would be, what is s sub 2? S sub 2 is equal to 2 times s sub 1 minus 4. And I know that s sub 1 is 6. So I'm going to start plugging it in. So s sub 2 is 2 times 6 minus 4, or 12 minus 4 is 8. So notice that the problem had to include s sub 1 so that I could solve for s sub 2. If I didn't know s sub 1, I wouldn't be able to get a value for s sub 2. I don't know if my little face is over top of it, but I needed to know s sub 1. And once I know s sub 1, that's going to tell me what s sub 2 is. S sub 2 is 8. So now I'm going to plug that into the next one. So s sub 3 is going to be 2 times 8 minus 4, or 16 minus 4, or 12. S sub 4, right? To solve it, I needed that s sub 3. So I'm going to plug it in. 2 times 12 minus 4. So what I'm doing in each of these cases is if I needed s sub 5, I needed s sub 4. To get s sub 4, I needed s sub 3. To get s sub 3, I needed s sub 2, right? And so on and so on. It does feel lengthy. I want to show you one piece. This is 24. If I had to take this out much further, 24 minus 4 is 20. Notice that my difference is increasing. My difference here was 4. My difference here is 8. You could possibly guess, right? This is 2 times 20 minus 4. And this is about as long as they'd ever make you do. 40 minus 4 is 36. Notice what your differences were. This one went up by 4. That one went up by 8. This one went up by 16. So now you can start to guess. The next one would go up by 32, and the next one would go up by 64, and so on and so on and so on. So our sequence notation, we want to be able to read the subscript. So let's imagine, let me give you kind of not easier one, but let's say that s sub n is equal to 2 times s sub n minus 1. And I want to know what is s sub 4. Well, I would start with this expression. N has now been replaced by a 4. And so I'm going to replace it there everywhere. So s sub 4 is equal to 2 times s sub 4 minus 1 is 3. But if they didn't tell me what s sub 3 was, let's say they told me, s sub 1 is 5. I have to keep backing up. So if S sub 4 is 2 times S sub 3, then I need to know what S sub 3 is so I can plug it in. So S sub 3 is going to be 2 times. So again, if I replace the n with a 3, this is going to be one number smaller, n minus 1. So 2 times S with a little 2 subscript. But I don't know S with a little 2. I know S with a 1. So I got to go back one more. So if I'm looking for S with a 2 on the bottom, then this side is equal to 2 times S with a little 1. That's a term I do know. I do know what S with 1 is. That's 5. So I'm going to plug it in. And I'm going to say this is 2 times 5 is 10. That means that the value of S2, the second term in my sequence, is 10. I'm going to plug that in here. 2 times, and plug in the 10. I then solve that for 20, which tells me what S of 3 is. And so for each one of these, if this is S of 1, I'd plug it in here. Once I use that to solve for S of 2, I plug it in here. I use that S of 2 to solve for S of 3, and I plug it in here. And once I use my S of 3 to solve for S of 4, then I have the answer to my question. You could go the other way around too. Yep, if they gave you S of 4 and you could go forward. Yep, you could go in any direction you wanted. And so in this case, S sub 3 is 20. So 2 times 20. The answer to my question here would be 40. Yeah, well, and so normally the pattern, I had a great question in the background. Can you, like, where's this, pattern? It doubles. Like, how can I catch it? I'm not going to worry about the pattern all that much if the things I'm looking for are only a couple of terms apart. But if I have to go a really long way, I'm going to start to look for a pattern. And so notice that this is doubling, because if I were to look at this sequence, like just in a row, like here's the first term and the second term and the third term and the fourth term and the fifth, right? How do I go from the first term to the second term? I multiply the first term by 2. And how do I go from the second term to the third term? I multiply by 2. And how do I go here? I multiply by 2. And how do I go here? I multiply by 2. So if I know that the first term is 5, the second term is 10, multiply by 2. The third term is 20, multiply by 2. The fourth term is 40, multiply by 2. The fifth term is 80. So you can start to look at it if this equation is simple enough, right? An alternative might be, like, for another one that feels kind of a little more simple, sometimes it's simple addition, right? So this would be saying that S sub n is equal to S of n minus 1 plus 3. And let's say the first term is 5. So now what I'd have is that each term after the first one, I find it by taking a term, I add 3 to it. So I'm going to add 3, and then I'm going to add 3, and then I'm going to add 3, and then I'm going to add 3. So if S sub 1 is 5, I add 3 to it, 8, I add 3 to it, 11, I have 3 to it, 14, and 17, and I can keep counting them out as far as I want. The biggest thing for sequence notation is you want to be able to read it. That this literally says for any term in your sequence, it's defined. You know what it is by taking the term right before it and adding something to it or multiplying it by something or what have you. They can even, if they really want to make it tough, they could say, all right, what about this version? This time they'd have to give you 2 terms. But what they're saying is that for any term in a sequence, it's the sum of the previous 2 terms. So if I told you that S sub 1 was 1 and S sub 2 was 1, I told you they were both 1, then to find S sub 3, It's their sum. S sub 4 would be the sum of the two previous to that one. So if you were to write them in order, which can sometimes be nice if the relationship is relatively simple, if the first term is 1, like they tell me, and the second term is 1, like they tell me, the third term is the sum of those two. The fourth term is the sum of those two. The fifth term is the sum of these two. The sixth term is the sum of these two, and so on. So each term is based on the sum of the two before it. The other beautiful thing about sequences is that if you're looking at one and you're like, I'm confused, right? These are a beautiful question to consider as a bail. Right? I love finding question types that are confusing for me. And the reason is because it gives me something that, like, sequence notation is about as easy to see as possible, right? Because it's the only thing that looks like this. Nothing else looks like sequence notation, literally. And so if you see this like subscript notation, and you know that working on sequences is like, oh my gosh, this is really confusing, then you just got really lucky, because an area that you don't feel comfortable in is also an area that's super easy to spot. That doesn't mean they're easy to do. It just means they're easy to see, right? And we're not going to try these next ones, but just to show you what they look like, right? Sequence S, they'll always use the word, S sub n. This one's got the S sub n minus 1, the S sub n minus 2. This one is sequence P sub n minus 1. This one is talking about a sequence with A1 through AN, A sub n, and then A sub n minus 1. They always look the same. They'll always have this subscript notation. And so the thing I love about a sequence problem is that it very much is easy to spot, right? In a sequence, this term is defined by this formula. Awesome. If you know that this is an area where you don't feel comfortable, that is a perfect thing to bail on. Perfect thing to bail on. Okay, so what did we look at today? We looked at functions. We looked at formulas. We looked at sequences. I want you more than anything to be able to recognize them if you're going to practice them. Right? We have an entire chapter in the 5-pound book about them. No, they are not super high frequency. These are much more minorly tested. Much more minorly tested. Exactly. It's a big yay for that. You want to be able to, if you're going to try these problems, you want to feel comfortable translating weird notation. And sometimes when you look at those patterns, instead of seeing the formula, if you can see the pattern, each one doubled, each one got bigger by 3, it can help you get through the problem a little bit faster. These are also awesome problems because they are easy to spot. And so if any of these are like, oh my gosh, that was really hard, you just found a question that could buy you an extra 2 minutes on the test because you know not to do it, right? Which is as awesome as anything else. When you have a list of questions where you're like, I know that this isn't a question I want to do. It's like magic. Okay. I had a couple of Q&A questions in the background. There are GRE prep hours that are already up on our YouTube site that focus on reading comprehension, that focus on vocab, that focus on the logic-based questions and verbal in general. This will be a recording on YouTube. Yeah, so it will be there. If you're going to take the GRE from home, go to our site. At the very top of our site, we have a ton of updates and notes and our blog article that talks about what to be thinking about and how to prepare if you're going to be taking the GRE from home, so the online version instead of in a test center. I think there are pluses and minuses, right? Pluses and minuses. And faster ways to solve word problems, yes, there are. I would highly recommend that you check out, we have a whole bunch of YouTube videos on estimating, working backwards, plugging in your own numbers, ways of avoiding doing like the sort of lengthy work for a word problem by using alternative methods. Tips for figuring out which questions you should bail on. Great question. This is why I like a timer counting up, right? 2 things. When I practice and I try a bunch of different information, I'm going to start to see which types of topics that I don't care how much time I spend. They're confusing and I'm probably not going to get them right. Those are great places to bail. The second is, okay, I can get these questions, but they take me forever. So I might flag them. I'm definitely going to like skip them on my first pass, but I might flag them and come back and look at them if I have extra time. So what you're looking for, what are the types of questions that you're like, I don't want to do this. I don't care how much time I had. Versus if I have a bunch of time left over, these are questions I feel comfortable with, kind of, but they're just really time consuming. And it's through practice. It's through trying different problems and then, keeping track. How long did something take me? Is this a problem that I want to do next time I see a test? The answer is often no. The answer is so often no. Yeah, of course. All right, guys, I thank you so much for hanging out and dealing with like a super dense and difficult family of question types. And I want to wish you the very, very best of luck with your studies. Good luck. And if you do decide to take on some more functions, formulas, and sequences, check out our strategy guides or our 5-pound book. We've got tons of practice questions for these and a million other areas there. And don't forget that you can try the first session for any of our courses for free. All you have to do is go to manhattanprep.com at GRE / or / classes, whichever one that is. I always confuse them. But thank you guys so much. Hopefully we'll see you around the water cooler, see you around class. Good luck with your GRE studies. Good luck with the pandemic. Stay safe out there. Masks, hand washing, all the things. Otherwise, have a lovely rest of the evening. And congratulations, we made it halfway through 2020. Who knew? Who knew? All right, guys, thanks so much. Have a lovely evening.